and beverage industry are expanding rapidly all over the world. The dairy industry is one of the high-demand industry due to the nutrition provided by milk, offering a lot of benefits to the human body. Milk often contains a lot of calcium, protein, and other nutrients that are helpful for keeping your body healthy. Since China has reported a mortality case after it was discovered that milk contained melamine, the contamination can be considered a risk. However, the problem is that the existing technology is not able to cope with the contamination issue that arises in beverage production. Current technologies such as X-ray give off hazardous radiation and has limitation in detecting foreign objects below 1 mm. Therefore, this project aims to investigate the capability of any ultrasonic tomography system to detect the existence of foreign objects that are less than 1 mm.
In Islam, our religion also teaches us to avoid something that can give negative impact to ourselves. Prophet Muhammad had said, which is la darar wa la dirar from Sahih Muslim, means that no harm and cannot give a harm. It shows that Islam cares about the things that bring benefit to humanity as a whole and prevents them from committing harm to self and society. This research is one of the ways to prevent yourself and the public from consuming contaminated food that can cause injury to the community and even cause death. Before starting the project, here is the methodology flowchart for the simulation project, starting from research studies, identify parameters, design the ultrasonic or sexual modeling, perform simulation and analysis the result for validation process. The design for the model of ultrasonic tomography is being constructed using console software with appropriate measurement as the actual small carton touch lady 70mm x 50mm made packaging. Based on the literature review, 333 kHz ultrasonic sensor with diameter 9.3mm is used. There are 9 transmitter and 9 receivers located around the rectangular shape. After the design phase is completed, several simulations will be performed by computing the suitable frequency according to the foreign object and beverage packaging as tabulated in the table. We start the simulation when consider only a milk packaging as a reference model. We can observe the ultrasonic wave from the transmitter propagating through the homogeneous milk packaging model and being sensed by the receiver. There is no diffraction that may occur due to the absence of foreign object. Meanwhile, the graph shows the input and output signal that come from the transmitter and receiver. Next, the table shows the simulation results when the 1mm and 0.5mm of metal as a foreign object located at 2 coordinates. We can see the flow of wave propagation have been changed for each of the situations when the existence of metal piece. The next simulation results when the 1mm and 0.5mm size of plastic are used as a foreign object are located at coordinates x equals to 6, y equals to 60, and x equals to 30, y equals to 35. We can see the flow of wave propagation that has been diffracted clearly by the existence of plastic piece. Lastly, the table shows the simulation result when the 1mm and 0.5mm size of hair as a foreign object are located to the left and to the center of mid packaging, respectively. We can observe both conditions in the flow of wave propagation when there is a hair piece. Firstly, we perform an analysis on the output voltage from the 80 data collection. For position to the left, we can observe that the data is not overlapping at the right side. The dot plot shows when the size of foreign object is bigger, the output voltage will become smaller. However, when the foreign object located to the center, the dot plot shows the data is overlapping. This indicates that the location of the foreign object between the transmitter and receiver affects the signal. Therefore, when location of the foreign object is closer to the transmitter and receiver, the 1mm and 0.5mm of the foreign object can be distinguished. Second, the simulation is performed to analyze the median of the 80 collected data points for every size and position of metal, plastic, and hair. The median of them will be subtracted from the median value of the homogeneous condition. The dot plot shows that the data were not overlapping with each other, which means each of the foreign materials had a different output voltage from the initial condition. Thus, this conceptual modeling can distinguish foreign objects below 1mm from the initial condition.
Although this project is still in the simulation stage, the simulation output will eventually be transformed into hardware that can produce unique real-time monitoring. This will improve commercial machine capabilities. Additionally, it could improve the beverage quality by reducing contamination, as it achieves the objective of SDG 9, which provides the necessary technology solution. This technique will be expected to boost demand for the food and beverage industry sector, manufacturing, business, and supply. Because this method has been proven to be successful in identifying foreign objects smaller than 1 mm,